Okay, in this video we're going to look at the coupling forces between each part of this particular train. So it says a toy train consists of two engines, each of mass of 1.6 kilograms. So we've got one engine here and the second engine here with a passenger carriage of mass of 0.8 kilograms. We've got a passenger carriage here, coupled as shown in this diagram. So here's the front, the middle and the back. The resistances to the forward motion for the engines and the passenger carriage are 4 newtons and 2 newtons. So this one and this one has a resistance of 4 newtons and this one has a resistance of 2 newtons. The front engine has a driving force of 20 newtons and the train is moving along a horizontal straight track. Calculate the acceleration of the train. Calculate the coupling forces acting on the passenger carriage. If now both engines have a driving force of 12 newtons, in the same direction, calculate the coupling forces of the new coupling forces of the passenger carriage. Comment on your answers. Okay, to do the first part, we just keep the train as one object. So here we have the whole train. We just treat it as one object. So the total mass will be 1.6 plus 0.8 plus 1.6, which is 4 kilograms. We just treat that as 4 kilogram mass. We've got the driving force, which is 20 newtons, and we've got the total resistance to motion, which is going to be 4 from that one, 4 from that one, and 2 from the middle one. So it's 4 plus 2 plus 4, which is 10 newtons. Right, we've got to find the acceleration. We're going to assume it's moving in that direction, so therefore we're going to say the D, the driving force, minus the resistance force is going to be equal to the mass times acceleration using Newton's second law. So putting the numbers in, we're going to have 20 minus 10 is going to be equal to 4 times my acceleration. 20 minus 10 is 10 is equal to 4a, therefore a will be equal to 2.5 meters per second squared. So we've now got our acceleration. Right, we're now going to calculate the coupling forces between of the carriage. So in order to do that, we're going to draw separate diagrams. So starting from the back, we've got the weight, which is 1.6 kilograms. It's got a tension T2, which is one of the coupling forces we're going to find, and it's a resistance motion of 4 newtons. The passenger carriage has a weight of 0.8 kilograms. It has the same tension, so we'll call that T2 newtons, as this one here, and it has a resistance to motion of 2 newtons, but it also has another coupling force, a different one, which we're going to call T1 newtons. Now we've got the front carriage, which is 1.6 kilograms. That's going to have the same coupling force as this passenger carriage here. It's going to have a 4 newton resistance to motion, but it has a driving force of 20 newtons. We have an acceleration of 2.5 meters per second. We're going to say the train is moving this way. So working out the equations of motion of each part separately, then we're going to have T2 minus 4 is going to be equal to 1.6 times our acceleration, which is 2.5. For this one, we're going to have T1 minus T2 minus 2 is going to be equal to 0.8 times 2.5. The front one, we're going to have 20 minus T1 minus the resistant force, which is 4, and that's going to be 1.6 times 2.5. Simplifying this one, we're going to have T2 minus 4 is equal to 4. 1.6 by 2.5 is 4. That gives me that T2 is 8 newtons. And this one, we're going to have T1 minus T2 minus 2 is equal to 2. And therefore, the difference between the two coupling forces, T1 and T2, will have to be equal to 4. This one, we're going to have 16, 20 minus 4, minus T1 is going to be equal to 4, 1.6 minus 2.5. And that gives that T1 will be 16 minus 4, which is 12. Okay, so these are the two coupling forces. Therefore, the coupling forces are going to be 12 newtons and 8 newtons. This one being 12 and this one being 8. And notice if you were to substitute in the middle one here, 12 minus 8 would actually give you 4. Okay, in the last part, it says if now both engines have a driving force of 12 newtons, so we no longer have a 20 newton force here, we have a 12 and a 12 in the same direction. Calculate the new coupling force, passenger forces of this carriage, and comment on our answers. So, using the same sort of diagrams, we've got the back here, which is 1.6. We've got T2 newtons here. We've got 4 newtons. We've got an extra force now of 12 newtons because it's got a driving force. Our passenger carriage is going to be 0.6 kilograms. It's going to have the tension here, a 2 newton resistance, and a T1 coupling force acting in that direction. And our front carriage is going to be 1.6 kilograms. That's going to be T1 newtons, 4 newtons, and 12 newtons. By the way, you don't need to draw these like trains. You can just draw them as blocks. Okay, and now we just do what we've got to do is find the acceleration, because we have a different acceleration because we've got different driving forces time. So the equations of motion, doing each one separately. So this one's going to be T2 plus 12, because they're both acting in the same direction, minus 4 is going to be equal to 1.6 times A. This one is going to be T1 minus T2 minus 2 is equal to 0.8A. It's not going to change, but the value of A will be different. And this one will be 12 minus T1 minus 4 is going to be equal to 1.6A. Simplifying these a little bit, we're going to get 2 plus 8, 12 minus 4 is equal to 1.6A. And that gives that T2 is 1.6A minus 8. This one will become 8 minus T1, 12 minus 4 is 8, is 1.6A. Therefore, T1 will be 8 minus 16A will be equal to T1. We'll call that 1, we'll call that equation 2, and we'll call that equation 3. And what we're going to do, we're going to substitute 1 and 3 into 2, and that will make that equation in terms of A only, and then we'll substitute back to get T1 and T2. So we're going to have T1, which is 8 minus 1.6A, minus T2, so we have to put minus in brackets, make sure you put the brackets in, 1.8 minus 8 from here. Don't forget to do the minus 2 is equal to 0.8A. We now solve that equation. So we get 8 minus 1.6A minus 1.6A, minus times a minus is a plus. 8 minus 2 is equal to 0.8A. 8 plus 8 minus 2 is 14. Minus 1.6A minus 1.6A is minus 3.2A is equal to 0.8A. And then we're going to have that 14 is equal to 4A. That's 0.8A plus 3.2A. And therefore A will be 3.5. 4 goes into 12 3 times, and 2 left over. 2 over 4 is a half, so it's 3.5 meters per second. Right, now substitute back into equation 3 to get T1. So we're going to have T1 is going to be 8 times 1.6 times my value of A, which is 3.5. So that will be 2.4 newtons, and that's positive. Therefore, that coupling there is in tension. And then from equation 1, which is this one here, we're going to have that T2 is 1.6 times 3.5 minus 8, and that's going to give me minus 2.4. So basically that means that this one is not in tension, but it's going in the opposite direction, therefore it is in compression. So our comments are going to be that this coupling here will be in tension, this coupling here will be in compression. Okay, so this has been a video to show you how to find the coupling forces of a connected object. I hope you've understood, and I thank you very much for watching.